sitting down for two reasons today. One is I don't have my microphone, and the other is because I'm still a little tender here. Okay, let me talk a little bit about the project here. Right here. Oh, my courses. My courses right here. Okay. Okay, let's look at here at this final project again. Right there. This is what you have to do between now and the end of the semester, so let's spend our time here talking about that. Everything that's going to be on the final, I think, has been covered there, although we will have a session next week kind of going over what's going to be on the final in more detail. As I understand it, we got, what, 2 weeks of classes left? That there? 1 week? This week and next week, is that it? And then you've got 2 weeks to study. Is it 1 week or 2 weeks? I thought it was 2 weeks. No, I'm talking about after next week. That there you have 2 weeks to study with no classes. Your study period's 2 weeks. Is it 1 week? I hear conflicting. Okay, well, regardless, before the last meeting next week, I want to spend a little bit of time reviewing what you should be looking at on the final exam out there. So, but today I want to give you the information you need to finish this project right there. So, right there. Okay, first off, you should have finished already you should have finished this project where we did the timer, the interrupt service routine for the function start timer. Right there. You should have finished this. If not, you're going. I put the solution up there, because you will need this for the final project. Right there. So everything on this last lab that I put the solution for, you're going to need for the final project. Right there. In particular, you're going to need to leave. Ignore this right here. We'll talk about this. We'll talk about a few more things here. I actually kind of prepared some notes here to make it a little quicker, so I have to type everything here. But what you'll still need to initialize your ports. We'll talk a little bit more about that here in a couple minutes. You need to initialize your timer right there, and then of course your interrupt service routine. We made changes on that the other day. I used XYZ right there as our right there. If I recall, start timer, I said numsec is equal to this right here. XYZ is one that we just set to 10. That was an arbitrary variable, as we call, in order to get a 1 second delay right there. And nsec is what we use to count down that there. This here, we can turn off these LEDs. We don't need those for the final project. That was just a test at that particular lab. You'll want to use those LEDs for other things on the final project. So to save wiring, you'll want to use those LEDs. So these two lines right here, you can just basically just delete right there. Hang on, right there from that code. That there. So let's get back to the final project right here. Right here. Here's the final project. Now, I'm going to go through this using the notes from another course, the final project that's a little bit simpler. I don't have the optional fourth rinse or third rinse there. I'll talk about how you handle that there. But this is the basic outline for this project right here, right there. This is the basic outline for it right here. Actually, I'll cut Right there. And what I've done here is I've copied and pasted that right here. Now, again, I left off the last couple here. Let me just go ahead and put them on there to make it complete. Right here. I'll just grab the whole thing right there. Copy. That way it's complete. Right there. Okay. All right. This is the format for a finite state machine here. This was from an earlier class. Yeah, they don't seem to be working. So, right there. So this is from an earlier class where I gave the basic format for the select case and how we would apply this to a finite state machine. So as we look at this particular project, I'm going to cheat a little bit because I already did this in another class, so I'm just going to bring up there. Now again, keep in mind that you do have this start time available to you. I won't get back to that there. So this is the format that we want. So let me go ahead and look at here. What I've done here is I've cut and pasted that list there. Now, as we look at this right here, let me just kind of right here. This is our list of states right here. See, this is our list of states. Now, we don't need to know what they are, but here is our type definition from that example. You know, what we have to do is we have to list all of our states here. Now, this one's missing a couple right here. This is missing a couple here, but any state that's listed here, I have to have listed on the left side. And what's listed on the left side here is what I'm doing is I'm editing our blinking program from our last lab. I'm just adding to that right there. And that's about as easy a way of doing this project as right there. So I go into main right here, and I go into it, and I'm going to define our type right here. And I list here, now I added some states here. You'll notice some states have been added. Wash start, spin start, rinse start. Any place that there's a timer, I added a new state. The reason I added that new state is to start the timer right there. So if I go back to my list of states right here, you'll notice that here under wash, wait here for 15 seconds, right there. Right there. Over here, I added a state called wash start. Over here, I have right there. I have a state here, spin 1 for 10 seconds. Over here, I got a state here called spin start, spin 1 start. So I added some states right here. Now, not all the states are over here are been added. That there, but that there. But you would go through here, and this is the format. You know, so I just simply make sure that every state that's on the right side here, and this is cut and pasted right out of the assignment right there, that I list every state, including the ones that I added for starting the timer. So I should have, I counted in this case about 19. I don't know how many you'll have when you add all that there. So you set that up, and what we're defining here on the left here is a type definition. So we start with type definition. It's an enumerated type. In other words, it's going to be a list of various states. And we're going to start off with our initial state is idle. That's our default state right there. And we list all the possible states we can have right there. And this is my state type right there. Right there. This is in Word, that's why it's underlined that there. So, let me just make that go away. We're all right there. So, my state type, and here I'm defining This is the variable declaration right there. So I now have a new variable called state. I'm going to initialize it to idle, and it's of type my state type right there. So those two lines, two sections of the code define our finite state machine. This is a list of all the possible states. This is what we're calling our state machine, a state, and this is our reset state right there, this item. So that sets that up there. This XYZ, numsec, and nsec, this is all from the last one. You'll need to keep TE there because TE, as I said, has to be a global variable right there. Nsec, you don't necessarily need there. XYZ you need there because that's what we set that in our interrupt service routine. So XYZ is there, but numsec we need right there. So port initialize, we still need to initialize our ports. We still need to set up our interrupt, and we still need our function start timer. And we're going to have a few other functions we're going to add later here. So now we go back to main here. And in our port initialization, I'll talk about that in more detail here. Main is going to remain, we're still going to go ahead and disable the watchdog timer. We don't have time to spend time looking at the watchdog timer, so we're going to disable it. We're still going to set up timer 2 and enable the interrupts right there. So timer 2 is still our interrupt. This is still going to generate an interrupt 10 times a second. And we'll look at that interrupt service routine. It doesn't change from the last time. This is now what we're adding here, and this is our switch state right there. This is what I started this. I'm not going to finish this. This is your job to finish this right there. So, but switch and state right there. That's the name of our state variable. If we're in the idle state, we look at our input called start, and if it's equal to 1, we go to our fill state. Otherwise, we stay in our idle state. And we break, we're done. If we're in our fill state, if we're full, if full is equal to 0, if you remember looking at the spec there, I said that full was an active low. If you use one of the push buttons, you can change that. That there. We go to start, otherwise we stay in fill. That there. If we start our wash, and now in start wash, we don't have an if then else statement there. We don't need one there. Because the only thing we do in start wash is we start our timer. Right there. So we just start our timer in this particular state. Right there. So we start the timer, we pass at 15, and there's probably an error. Start timer, okay. I don't guarantee this to be free of syntax errors. That there. The concept here is what I'm trying to get across here. So we start the timer, and we're going to pass at 15, and the 15 comes from right here. Wash for 15 seconds, right there. So we're going to wait there for 15 seconds right there. So we go into our wash state. In our wash state, we're waiting that there. If TE is equal to 1, and TE is our variable for time expired, it is set. In start timer, we set it to 0, and then when our interrupt service routine counts down to nsec is equal to 0, it sets TE high. So TE is an internal variable right there. So when TE is high, it means our 15 seconds have passed. That was the whole purpose of the lab last week, was to be able to set up this variable time delay. So we go in here to, we start the timer right here with this command right here. And all we do is we just call start timer, and when we call that sets TE to 0, sets numsec to 15 and sets our next state to wash. When we go into wash, if TE is 1, we go to our drain state, our first drain state. Else, we stay in wash. So we just keep washing for 15 seconds. So we'll just stay in this state until that TE goes high. Now, if you look at this code without looking at the way the interrupt service routine works, this looks like this shouldn't work because TE is being taken care of outside this loop right there. So we go through that there and we break. And we go through and we just expand this. Our next case is what? We would just go through case. Our next state is drain, right? And I don't know whether it's capitalized. You need to make sure your capitalizations are matched up right there. And is it capitalized? I think it is capitalized. Drain. Yeah. So you need to make sure that it's capitalized here too. Right there. Drain. Next state. So next state is drain. And then we would go through there and drain, we're looking at if empty equals 0. State is equal to whatever it is, then it's what, fill 2, something like that, or fill 1, right there. Fill 1, else state is equal to drain, right there. Right there. So, and you just go through and you complete this entire table for all that there. So that's how you can do the finite state machine right there. So we go through that there. Now we also have to look at our inputs or outputs right there. We have 4 inputs here, right? Right there in your particular case. So we have to have 4 inputs, and those can be whichever they want to be right there. At there. You can use 2 of them on the push button right there. The push button can be 2 of those. The other 2 have to be external LEDs. So if you look at your chip right here, this is your chip right there. Right there. Here's your chip here. And now you'll see our 2 push buttons are on port 2.1 and port 1.7. So those are our 2 push buttons right there. And then you look at the wiring on those. As I recall, those were right here, the push buttons. As you can see, those have got external pull-up resistors right there. So when you push the buttons, they're taken low, so these are active low push buttons. So if you don't push the button, it's high. So that works for active low. So actually you would probably want your start to be active low too as well, right there. You would hook up any wire, any inputs you would hook up the same way. Because you're going to need 2 more inputs because there's 4 inputs, right? Right there. So those would go through right there. Right there. So as we look at our chip right here, we've got, those are our 2 inputs right there. We also have our 2 outputs right here. Our outputs, again, going back to our schematic. You can see, where's our outputs here? As you can see, our outputs are pulled high, so these are active low outputs. out there. And again, that's how you would connect up any external LEDs as well right there. So these are our ports that are connected. So don't use those for your external ones right there. So 1.0, 1.1, 1.7, 2.1, and 2.2, or 2.1.2, those 4 pins are already spoken for. You can use them, but don't connect external components to them. Right there. Use them only internally. So going back to page 2, right there, that tells you that here we've got port 1.7, don't use that one. We can use 1.3, that one's available to be used. 1.2 is available to be used. 1.1 is not available to be used, it's used here. 1.0 is not available to be used, it's used here. 0.7 is available. 0.6 is available, 0.5 is available. So everything on port 0 is pretty much available to you. So you could actually do everything on port 0 right there. So that there. So port 0 is available that there. Don't use anything, you know, this is ground, this is ground. This one is CD2, you won't use that one. C2 clock, that's for programming, you won't use those pins right there. So those are the ones that you'll use right there. So, you know, I would just use port 0, but you can use whatever ports you want right there. And remember that we plug this board into our little prototyping board, and you'll connect to the external world from that there. So, okay. With that said, right here, you also need to, again, modify that right there. Right there, you just basically go through and you finish this finite state machine right there. That sets up your finite state machine. Now the other thing that you need to look at right here is that right here, these are setting up, these were used for our lab right there, and they did say port that there. I went ahead and changed them to say fill valve and drain valve, for example, or start right there. So you need to set up your 4 inputs right there and your 4 outputs right there. So, and you need to also add, what did I call it? Clean, whatever that other input was. Water sensor. So you have water sensor right there. So you have 4 inputs and 4 outputs right there. So I specified that there. So you would need to set up one of these lines for each of those right there. So the same thing here when you set up port initialize. Where are we at here? Where's our port initialization routine? Find global constants, global variables. There's your finite state machine, function prototypes. Your main, it's actually down here underneath there. Your state, we'll talk about. Your port initialization right here. You need to go through and enable your LEDs as push-pull outputs, or however you want to set them up. Again, I'm leaving that there, but you need to set up your ports. So you would also have a line here that would be port 0 mod out, and I can't find the magical key, equal 0x, and I'm just going to say XX00. You have to look up what that's going to be, and this will probably change too, right there. So these 2 lines you'll have to make changes on there to set up, initialize your ports for what are your inputs and your outputs. right there. And you may have one for mode 2, port 2, because as I recall, actually looking at this right here, now, right there, yeah, this push button's on 2.1, so you'll have to have another line here for port 2 as well. So you have to modify port 2 as well at that point. So you may have to modify 3 ports here. Port 0, 1, and 2. You'll have to write to all 3 of those at there. So, and typically you just set a 1 to whichever one you're going to, right there. And actually, if you want to set a pin to an input, you have to also write a 1 to it. So you would have to write. So if you set a pin to a 1 input, you would still enable as push 1. You also write a 1 to that pin. You set that output high, and then you can read it right there. So again, we talked about that earlier. You may not remember that, but that's there. But for right now, I want to concentrate on what you need to do. Now, this is the setup for setting up the state transition right there. So this is in your while loop. Again, everything else is the same right there. So let me just go back to the start of our code right here. This is the start of our code right here that you're going to have. This is called Blinky. You probably ought to change the name to Final Project or whatever right there. And you change that there. These includes stay the same right there. All right, this is the start of the code. These 2 lines will remain there. Those are with any program we were to write this semester. We have to have those 2 lines. Our global constants, our clocks, system clock is not changed. We leave that the same. We need to specify what am I doing here? Okay. Getting back to this right here. This specifies we need to specify all of our pins right there. In other words, we need to specify what our pins are. I just put 3 of the input pins I specified. We would do the same thing for actually these 2 are output pins, and this is an input pin. So we said S-bit start, it's on special function register port 2 bit 1 right there. I got that because I'm using the push button right there. You can set that there. So you would have one of these for all 8. You should have 8 lines that start with this one, with this S-bit right there. That defines your 4 inputs, your 4 outputs right there. So we've got 2 motors. I just set them because they're 2 separate motors. You could call it spin motor or wash motor if you want. Or you could call whatever you want right there. But we've got full start, empty, and water sensor are 4 inputs. And motor 0, 1, fill valve, and drain valve are 4 outputs. So we specify those right there. The next thing we need to do, and this is not finished, I just started this right here. This is our type, enumerated type. We list all of our types. I said idle is equal to 0, and you list all your types. Be sure you put a comma after each one. I don't have the comma, and I can see you're dozing off in the front there as warm as it is. I'm trying to go as quick as I can through this because I know it's warm. It's hard to stay awake on the equivalent of a super Monday, right? Yesterday was Monday, but since Monday was a holiday, this is a super Monday because it feels worse than a Monday. So it's super Monday. It's worse than a Monday. So, but this is important because this is how you're going to get through this final project. This is step by step how you do it, right there. So, here's your type definition. You set up your finite state machine. You list all your states. Now remember that I added these start states right here. Those were not in the original assignment right there. I added those. Any place where I had a timer, I had to add a new state. Once I define what my state machine looks like, I have to define the state variable and its initial state. That's this line right here. These are XYZ, of course, was used internally. I just, inside the interrupt service routine, just leave that there. Numsec, we need to leave that there because that's a global variable. You don't have to initialize it to 0, but you have to still declare it. NSEC we're not using, so you can delete that one there. In this particular one, TE you have to leave there because that's a global variable that we're using that there. So we have to go ahead, NSEC we can delete that there. Our function prototypes, we have the same 3. Our port initialization, we have to modify that one. Timer 2 initialize, we leave that the same. We're not going to change our timer. That there, we did that last week, or supposedly, I think you had it working, right? A couple of groups I saw had it working last time. But that there, but we set that up. Main, we go ahead and disable the watchdog timer. We initialize our ports. We initialize our timer. And turn on our interrupts. Then we go into our finite state machine transition table. Right there. I started this for the first 5 or 6 states. You go through and finish that. Now what we are missing right here is that we need a second select case. I haven't talked about that, but let me just go ahead and go through it here. The second one is, it looks exactly the same. Matter of fact, I would just cut and paste the first one. That there, and all you're doing is you have 4 outputs for each state, right? Just say what they have to be for each state right there. You could do that within the same one, but that complicates it. I prefer to do it in a separate one. So when we're in idle, both our motors are turned off and both our valves are shut, right? Now that may be one. I'm just saying you decide what defines on or off right there. And you do that for every state right there. Right there. And that's it. That's your final project. That's everything you need to know to finish that final project right there. Yeah, right there. If I did any more for you, I have to sit there and write the code and give it to you. That there. That outlines it step by step what you need to do. Now you have to fill in the gaps. You have to finish it. But I started that there. So again, you've got, the only other thing that I have not talked about here is your port initialization. I mentioned the fact that you're going to have to modify that for whatever ports you use. So your port initialization routine will have to be modified. Look at which ports you're using, which ones are inputs and outputs, right there, right there. And the rest of this stays the same. That's the final project. With that said, I am going to stop my recording. I'm going to let you go and try to find someplace, either get some caffeine or find someplace cool so you can wake up, or go back to the hospital and take a nap, one of the two, whichever one you want to do, right there. But that's the final project. This week during lab and next week during lab time, all I'm going to do is just let you work on this, and I'll answer questions out there. So, that there. I will post this